My lock is really like
Is that a rule?
Yeah, that's what it is.
Okay. Yeah, it always been a rule. That's true.
No,
All right. So, rotations. You guys know what it means to rotate something? Oliver just had to rotate his combination lock on his locker to open it. Or did you crack it?
what? No, I opened it.
You had to open it?
Yeah.
Okay. Oliver, which direction did you rotate first? Clockwise or counterclockwise?
I don't know.
Clockwise.
No.
Clockwise.
To the right,
Yeah.
which would be what?
Clockwise.
Clockwise, good. So we're going to talk about rotations with respect to some of them being clockwise, some of them being counterclockwise, okay? All right, so a rotation is just a transformation that turns every point of a pre-image, okay? Now it does it at a specified angle, and I'll show you what that means in a picture, and it does it also about a fixed point. Today our fixed point is going to be the origin, okay? Tomorrow we'll talk about our fixed point being something else, okay? So this is going to be about our origin or about 0, 0, okay? So about origin, which is just going to be 0, 0 today, okay? All right, now, again, we're going to talk about it by doing things going clockwise and also things going counterclockwise as well too, okay? Now, when I rotate something, is that going to change the size or shape of that object? No. We'll change the orientation, which is the way it's facing.
Yes.
Yes, absolutely, but it's not going to change the size or the shape. So it's a congruence transformation, okay? All right, so we're going to do a little exercise first before we write our rules. We're going to take a coordinate point, -6, 1, and we're going to rotate it according to those degrees. Now, those are the most common degree rotations that we'll look at. So really 90, 180, and 270, but we'll include 0 and 360 there. What's that? We're just going to focus on these. When we talk about rotational symmetry, we'll talk about other degree values, but these are the ones that we're just going to focus on, okay? Now, let's say I have the coordinate point -6, 1, okay? So I'm just going to make a graph off here to the right. 1, 2, 3, 4, 5, 6. I would encourage you to do the same. If you don't, that's okay. But I'm just going to do 6 in each direction, okay? All right, so my coordinate point, what do they say? A is at -6, 1. So 1, 2, 3, 4, 5, 6, 1. So we'd say here's our original value, okay? Now, this is telling me rotate clockwise. So let's rotate my coordinate point A clockwise 0 degrees. Is that going to change anything? No. So my coordinate point will remain as -6, 1. So my rule for that, x and y didn't change, so we're just going to say xy. We're not going to put anything in our middle row. We're just going to put things in our top row and then our bottom row as well. All right, but more exciting, let's say we actually rotate it 90 degrees, okay? So in your head, what I want you to do is imagine rotating that green point A clockwise 90 degrees. Which way am I going to spin?
Right.
To the right. Now, I want you to think roughly about where it's going to land. We're rotating it about this point here, okay? So that's like our fixed point. So that distance will remain the same, but I'm rotating it 90 degrees,
Yes.
okay? What quadrant would you expect it to land in?
Quadrant 1.
It's going to be in quadrant 1. Specifically, it's going to be right here, okay? So that's going to be our A prime value.
Oh, you just flip the x and y, right?
Close. There's something else you do with it as well, too. This coordinate point is 1, 6. It came from -6, 1.
You split the x and y.
So you swap x and y. I agree with that.
Positive and negative.
And then you change the sign of the value that lands in the second spot. Okay? So then this becomes the coordinate point 1, 6. And our rule for that is you swap x and y, but then you change the sign of the one that lands in the second spot. So it would be y -x. You change that initial x value. That's going to change sign. And then you swap them. Yep.
And then
X changes too.
Yeah. Was that a knock? I don't think so. Okay. All right. Now, here's something else I want to show you on the graph. Okay. If you connect A and A prime to the origin, let's see what happens. So A and A prime, I connect that to the origin. What did I make?
An angle, a right angle.
A right angle. And I rotated it 90 degrees. So that should make sense why it is a 90-degree angle. Now, it roughly looks like a 90-degree angle, but that's what it should be, is 90 degrees. Okay? All right, now, let's say I want to rotate A, this time 180 degrees. So what that means is it should form a straight line between A and wherever A prime lands. What quadrant would you expect that to happen in?
What'd you say?
What quadrant, if I rotated it 180 degrees, this point right here,
Oh, quadrant 3.
it's not quadrant 3.
What is
Quadrant
Quadrant
one
four.
is the-
Technically, it's quadrant 4. You're probably thinking of the right spot, but it's going to be over here, Carter.
1, 2?
Shut up.
1, 2,
Oh,
3, 4. All right. Now, if I connect this with a straight line, that's 180 degrees. So that should make sense why that's our 180-degree rotation. That coordinate point becomes 6, -1. So what did I do to get from this point to this point?
Change or flip the sign.
Of both things, right? Both x and y are going to change sign. So 180 degrees would be 6, -1, and then my point becomes -x, -y.
Negative X, Y.
No, it'd be -y.
Okay, sorry.
Because and that brings up a good point. It's not about the sign itself, but it's about did it change sign? And if it did, then a negative needs to go there. Okay, let's say 270 degrees. So 270 is more than 180. So I'm just going to rotate this point 90 degrees more than 180. And it's going to end up like right there, which is going to be the coordinate point -1, -6. So then what did I do to get from this point to this point?
You flip them, I mean,
The coordinates swapped.
and then you change the original X.
Good. And then you change the sign. It wouldn't be the original x value, but it's the original y value that changed. So it's the sign of this one that lands in the first spot. So then this becomes, oh, I already did that. So then that coordinate point is going to swap and then change the sign of the one that lands in the first spot. So it'd be -x, y. What happens if you rotate something 360 degrees? Okay, so then xy becomes xy. Oops, I wrote that down below, not there. So that means -6,1 becomes -6,1. It just took a little bit of a trip, and then it becomes xy. So it doesn't change. All right, so then let's fill out this table down below. There are two directions with which we can rotate, counterclockwise and clockwise, okay? We just did the rules for the 3 clockwise rotations that we pay attention to. 0 and 360, nothing exciting happens. It just goes back to its original spot. So we focus on 90, 180, and 270. Let's rewrite the rules. So for 90 degrees clockwise, that was the rule y -x. For 180 degrees, that was -x, -y. And then for 270 degrees, that was -x. No. I messed this up, guys. Hold on. This one right here, I messed that up. I need to change that. Does anybody know what it should be?
Y negative X?
Negative Y.
Should be -yx. We were all wrong. I'm sorry about that, guys. I don't like to make mistakes.
apology not accepted.
Ah!
And make it clear.
Everybody makes mistakes.
Okay.
I've never even heard that song. I just know it's a line from a song.
What?
Wait, which one did we change?
The one for 270, Oliver.
What do we do instead?
We're going to change it to -yx instead of -xy.
Okay.
I'm sorry. So then this becomes -yx. All right. Okay. Riddle me this, Batman.
What?
That's a line.
You've never heard that before? No? Okay. It's from the Riddler. Yeah.
Really?
Huh?
This Batman?
It's from the Riddler.
But
Riddle me this, Batman.
that's not, that's too.
Just go with it. So if I rotate something 180 degrees clockwise, will that change if I rotate it 180 degrees counterclockwise?
Yes.
Will it? So like if I look back at my little makeshift graph here, 180 degree clockwise rotation we said was here. What would 180 degree counterclockwise rotation look like?
Oh my gosh.
It's the same thing.
Same thing. So because of that, the rule ends up being the same. So the rule for counterclockwise 180 degrees is negative x, negative y. Now what about for 90? What would you...
YX.
Yeah, it's just going to be the same as the 270 clockwise rotation. So that's going to be negative y x. And then for 270, what would that be?
Y negative x.
Good. Memorize them. You got to know them. I'm not going to give them to you on the quiz. You can do it. I believe in you.
Let's say you
Like
let us
the
use that
Thursday
for the
quiz?
quiz.
Thursday quiz. Yep. Memorize it for the Thursday quiz. This is my advanced organizer. You got to know it. Really, you only have to memorize one column because the other ones are the same if you remember to just flip them.
What do you, this is what.
So let's see that in action. Maybe once we put it to an example, it'll make
Let's see the whole thing.
some more sense. What'd you say? Is this what you're looking at?
Yeah,
You let me know when you're ready to switch.
I'm ready.
He's ready. This looks fun.
Like,
Okay. All right, triangle has these three coordinate points. Let's rotate it 90 degrees counterclockwise, about the origin. Okay? All right, so first coordinate is at 1, 2. So let's start by plotting my points. So 1, 2 is A. B is at 3, 7, all the way up here. And C is at 5, 5. Little tringle. A, B, C. What goes with pink? Purple? My daughters would be happy about this. All right, so then now we want to rotate it 90 degrees counterclockwise. So we need to go back to the rule that you guys wrote down on the last slide, and then let's rotate it. So then 90 degrees counterclockwise. All right, so that is xy turns into negative yx. That's our rule. All right, so then now what I want to do, my first coordinate point, 1, 2, let's find what A prime is going to be. I need to swap the coordinates and then change the sign of the one that lands in the first spot. So 1, 2 becomes what?
Negative 2, 1.
Negative 2, 1. It would become 2, 1 Oliver, but then change the sign of the one that lands in the first spot. B prime's at 3, 7. What's that become?
Negative 3, 7.
Nope.
Negative 3. I don't know.
Swap the coordinates.
Oh. I don't know.
7, or negative 7.
Good job, Jillian. And then C prime is at 5, 5 right now. That's the easy one. What's that become?
Negative 5, 5.
Yay. All right, so then our coordinate points, A prime is going to be at negative 2, 1. B prime is going to be at negative 7, 3. And then C prime is going to be at negative 5, 5. A prime, B prime, C prime. My purple graph should look like my pink graph, rotated 90 degrees counterclockwise. What do you think?
no.
Carter's not seeing it.
Yeah, it looks pretty.
I mean, it looks
good.
kind of the same like that.
Okay.
But
Well-
like,
That does not really.
yeah, it does not look the same. I changed my mind.
Okay.
Why
No,
do
it
B and
does
C?
though.
Why do B and C for
It's
the
the same.
pink one look longer than the other things?
Because Mr. Pacifico drew the graph, and that's usually what you get.
Fine, I
Mr.
guess
P
I'll-
draws a graph. But here's this. Like, what I should do is if I connect the points from my original points to the origin, and then from the origin to the image, then it should make a 90-degree angle. So if I go from here to here, and then here to here, does that look 90?
Yep.
For sure. And then if I do, it's going to be harder to see B. Oh, man, what happened there? It's going to be harder to see B because it's just going to go along that line, but it would look like from here to here, and then from there to there, I guess. And then for C, here to here, and then there to there. I would also say 90 degrees as well, too. So, okay. All right, it checks out. It works. 180 degrees is the easy one. Let's do another one. This is a cool color. Let's do this. All right, D is at negative 2, 4. E is at negative 4, 6. And then F is at negative 1, 7. All right, so D, E, F. Oh, I like this color. I wish I could just put it in the, like in one of these. You know what I mean? Can I do that?
Well, it'll be there. No, just click.
Yeah, but like, you know, tomorrow when I come back, it won't be there. All right, so that's all right. It's first world problems. All right, so D, E, F are there. So then I want to find my new coordinates. So I want to find D prime, E prime, F prime. Okay, so then D prime, E prime, F prime. So my rule would be X, Y goes to 180 degree rotation. What does that do? I just changed the sign of each one, right? Negative X, negative Y. Okay, so then D prime right now is at negative 2, 4. What's that going to be? Close. Positive 2, because that has to change sign as well too. Negative 4. All right, what about E prime? What would that be? Right now it's negative 4, 6. So what would that be? 4, negative 6. And then F prime is at negative 1, 7. What's that become? Great. Okay, cool. So then let's plot those. So 2, negative 4s down here. And 1, 2, 3, 4. And then 4, negative 6. Just like right over chair. And then 1, negative 7 would be all the way down here. So then that would be D prime, E prime, F prime. And if I connect all these points, I should be able to do so in a straight line that passes through the origin. So, yes. Yes. That one wasn't great. Let's try that one again.
I don't know about these.
There we go. Oh, it's looking good to me. All straight lines through the origin. I like it. Jillian doesn't like it.
So we're done with it.
What's that?
We're done with it.
Not even close, friends. We're going to the bell. I'm just going to tell you that right now. All right, write a rule to describe each transformation. There's a couple ways we could do this. We could either just analyze the points and just try to figure out what's happening, or we could plot each one and visually figure out what's happening. What would you prefer? Study the coordinates or plot the points? I'm going to make you do both either way. Which one do you want to do first? Study the coordinates?
Yes.
Negative 2, 3 turns into negative 3, negative 2. What did we do?
Rotated it.
Yeah, it had,
Y. Negative Y
okay.
and X.
So negative y(x) is what Jillian's saying. We swapped the coordinates and then changed the sign of the one that landed in the first spot because 3 was positive but then became negative. So what is that?
90 degrees counterclockwise.
Very good. 90 degrees counter.
How do you know if it's counter?
Yeah, how do we know?
That's a great question. Does it matter?
No.
could I do a rule? So if it was negative yx, could I do a rule clockwise compared to counterclockwise? So like a 90-degree counterclockwise rotation is the same as what?
90 degrees clockwise.
No, not quite.
270.
270. So it's the same as 270 degrees clockwise.
How do you know it's counterclockwise?
Either one of these answers would be fine. So if you said clockwise, then it has to be 270 degrees. If you want it to be counterclockwise, then it has to be 90. Okay? So Jillian, if you look back at like the rules here, you said negative yx, right? You see how that shows up 2 times here and here? So that's why either one of those answers would be okay. Okay? Now, if I graph it, just for the love of the game, let's see. A is at negative 2, 3. B is at 4, negative 5. And then C is at 2, 6. So A, B, C. Could do better than that. Maybe not. Okay, so then there's that triangle. That side from C to B is a bit wonky, so anticipate that looking weird. And then if I plot my other one, negative 3, negative 2 would be here. B would be 5, 4, which would be there. And then C would be negative 6, positive 2. Okay, so then it looks like this. So then this is going to be me trying to illustrate my point, okay? If I go from my green triangle to my blue triangle, if I wanted the shortest rotation, like the shortest degree rotation, you guys tell me, which way should I rotate? If I want the shortest degree, should I rotate to the left or to the right? If I'm going
Clockwise.
from green to blue.
Clockwise 90.
No, counterclockwise 90. If I go from green
Oh.
to blue, from green to blue, counterclockwise 90. Okay? Now, I could go from green to blue in a clockwise direction, but I would have to spin like most of the way around. So that's why it would be 270 the other way. Okay? All right. Okay, let's talk about rotational symmetry. If a figure can be rotated less than 30 degrees about a point so that the image and the pre-image are indistinguishable, meaning they lie exactly on top of each other, then the figure has what is called rotational symmetry. Okay? So the amount of possible rotations represent the order according to how many rotations less than 360 degrees. Okay? Now, we include 0 degrees when we talk about the number of rotations that we can have. Okay? All right, so for example, what type of shape is this? There it is. No, certainly not. It's a pentagon. And my question to you is, how many times can I rotate it such that it lies exactly on itself? How many times less than 360 degrees?
Wait, what?
Terrible worded question. Let me try it again. How many times can I rotate this pentagon, like spin it, so that way it'll lie exactly on its original image?
5.
Like how many
5 times within 360 degrees, right? Because if I rotate it, because there's 5 vertices, right? So if I rotate it for each one of those vertices, it would lie back on itself. Okay, so here's a question. We say 5 times because this is 0 degrees, and then I don't know what the rest of these degrees are. So that's my question to you guys. How many degrees would I need to rotate it so that it lies exactly on itself?
360.
Yeah, but like, you know, what else? That's tough, right? Do we agree it's not 90?
Yeah.
If rotate your iPad 90 degrees right now, what happens? Does it look like the same thing? No, one of those vertices is like in the middle, you know what I mean? It's like pointed out or whatever. So it's not 90. How do I figure out? It's not 270. It's a good guess.
Ooh.
360 by 5.
Oh, Jillian, yes. Take 360 and divide it by 5.
I was there. No, I wasn't.
What is that?
62.
Good, 72 degrees. So then the first one is, who's close though? 72. And then the next one would be 144. After that would be 216. And then 216 plus 72 is 288 degrees.
Hey, right,
So-
okay, good.
How do you get 144 if you just divided
Yeah,
70?
How would you get what?
How do you get 144 if you add 74? Wait, what? Because you're adding 74 each time. Oh, you're adding
72 each time, yeah.
Wait, but this is, or, yeah, 72.
Either way.
This
You,
doesn't make any sense.
doesn't make any sense?
Make it make sense.
Okay. Make it make sense? Let's say we have this.
Why are we not at 360 yet?
Oh, because if I do it one more time, then it would be 360, but we don't want to count that. So if I rotate this, because we know if I rotate something 360 degrees, it'll automatically be back on itself. Well, we're going to count 0. Or the other way you can think about it is don't include 0, and then instead just include 360. And then it would be 5. Let's say I have this one right here, and let's say it's symmetric, and Mr. P made a really good graph.
Good job, Mr. P.
Thanks. How many times could I rotate it less than 360 so it's that it lines back up on itself?
360 divided by 4.
Yeah, so it'd be 4 times. So 360 divided by 4 would be what?
Oh no.
360 divided by 4. 120.
Good,
no,
90.
90.
90.
So then you could just, every time you rotate that 90 degrees, it would just line back up on itself.
Jeez.
Okay? All right, we got 10 minutes left. We're going to talk about dilations.
No time to do homework.
Not today.
Maybe we just
You guys are just going to do the front side of a worksheet, though. I'm not going to give you anything on dilations, though. I want to talk at least a little bit about dilations. We'll get the basic notes in there, and then we'll resume it tomorrow. I was expecting to get through all of this today.
Were you?
Oh my god! Yes, I was, but I didn't, and that's just life. Hey, what does it mean if you dilate something?
You shrink it
Or?
increase its size.
Or
Bigger.
bigger, right? Bigger or smaller? When, yeah, like your pupils, right? Let's talk about that. Why do they dilate your pupils when you go to the eye doctor?
Look through your eye.
So they can look through your eye. You know that black part of your eye is just a hole, right?
No.
Wait, it is?
Yeah, it's just a hole,
Ew, I don't
Yeah.
like that.
right? We all learned something today. It's just a hole. And they open up that hole when they dilate it, and they shine a light so they can look at the back of your eyes.
You mean the pupil
Oh,
is
wait,
just a
can we
hole?
try?
Yeah.
There's a thing we try.
There's like a covering over it, yeah. So it's not like if you touch your eyeball, but like that part is black because it's just a hole in your eye.
Wait, but don't you
Imagine
see on
being
that
able
part?
to shove
The
things
part
in
you
your
see?
eye.
That's why there's a hole, so you can see.
I didn't know that. I must be
What?
You're lying.
I'm not lying.
Oh, the hole.
It's an opening in your eye.
See on the back of our eyes?
Well, like truthfully, I am
So it's
not
like-
smart enough to continue this conversation, honestly.
back of your
Because like, I don't know.
Did you see that?
Is that a bat? What was that?
That scared me.
What happened? Was it outside or was it inside?
It blew up. It was like huge.
Nyum.
I think it was a hawk.
That's pretty dope.
Your plant.
I wish I'd seen it. Anyway,
She was not normal. I think it was not a bird.
the last 2 minutes of this went really sideways.
That might have been a cat. Off the roof.
Oh my god.
No, define them.
Anyway,
High gravity.
when you dilate something, you make it larger or smaller.
Yeah.
It just fell down.
No, it didn't.
It just fell down.
When pigs
Can we go
fly.
look, please?
What was it?
What is it doing? That looks like it fell.
We're not going to be able to see it.
That looks like it was flying.
Oh, there it is.
What is it?
It's just a crow.
No, it was huge. No, it wasn't good.
It's just a crow.
No, it was not a crow. No, there must have been.
Look, that's a big old bird, but it's a crow.
It's a crow.
Is it on the floor? Where is it?
Yeah, it's over there.
Oh, it's dead. No, it's not. He's just walking around. He's chilling.
No, the first one you should have seen first.
It's just a big crow.
No, it's not.
That's
Yes,
all
it
it
is.
is.
That's exactly what it was.
It's just a
No,
big
it
crow.
was like a.
No, it actually covered up this whole window, I think.
Oh my God. Go sit down so I can finish talking about dilation.
No, there's a dead cat down there.
Stop it. No, there's not.
Yeah. Or there's some sort of nest or something.
Oh my God.
No crow would scare me flying through the rooms.
How do I cut this part out? Field trip to the window to look at a crow. All right. Anyway. When, it's a pterodactyl.
Oh my gosh, we learned that. It was fine last
I think the shade made it look brown. All right, anyway, a dilation changes the size of something, okay? So it's no longer a congruence transformation, but instead it's what's called a similarity transformation, okay? It changes according to what's called a scale factor. So depending on what your scale factor is, it tells you whether it gets bigger or whether it gets smaller. My voice keeps cracking. I don't know what's happening, but all right, either way. Could be puberty, I don't know. But either way, our point C, if we look at our black triangle compared to our blue triangle, we see that our image gets larger. And we dilate at about a certain point. Today we're going to talk about dilating about the origin. Tomorrow we'll go through and we'll talk about dilating at about a different fixed point, okay? Now, riddle me this, Batman. If your scale factor is bigger than 1, is it going to get bigger or smaller?
Bigger.
Bigger. We would call that an enlargement. If your scale factor is between 0 and 1, then we're going to say it gets smaller. We're going to call that a reduction. Okay. All right. And then we're going to say a dilation is a similarity transformation. We'll come back to that last part tomorrow, okay, when it's equal to 1. We'll come back to that tomorrow. All right, let me give you your worksheet. I'll give you at least a couple minutes to orient yourself. This is where I got last period anyway. Surprised I didn't get through all this. What happened? You know what? I don't know.
We started talking about
That's what it
It's
was.
not a throw, I promise. White and brown the first one, and then the second one that went down looked smaller.